Hello and welcome back to another VMK in the game development series. In this VMK we're going to start working with the GUI elements that we're going to be incorporating into the game engine. All of our GUI elements are going to work from an inherited class structure. So to begin, in this video, what I'm going to do is show you how to create the base class that everything is going to inherit from. This base class is going to contain all the properties that all different GUI elements are going to require. From there, we're going to create other classes that are going to derive from this base class and then specialize in their functionality. So from this base class, we're going to create a GUI button, which is going to be like a toggle button. Then we're going to use another class to create radio buttons, and another class to create a slider. You've already seen these in the previous VMK where I showed you how everything was working. But before we can go in and create these detailed kind of classes, we first have to understand the general structure. So let's go inside of PaintShop Pro here, and let's talk about the base class first. The base class is going to have a number of properties. First property is going to be its type. The type is going to identify the GUI element as being either a button, a radio, a slider, a text, something like that. It's going to identify exactly what kind of GUI element this specific class belongs to. Each element is going to have its own unique identifier so that when you click on it, we know how to respond to that certain action. So for instance, our type could be button, but with a button class, we could have 3 different kinds of buttons. So each of these 3 different kinds of buttons have to have their own unique ID number. So that's what the ID value is going to be used for, is to differentiate between similar kinds of GUI elements. The first type of GUI element we're going to create is the button. So I'm going to tailor this discussion sort of towards how we're going to create a button. However, think of all of these properties which I'm going to be describing as very general so that we can apply them to sliders, radio buttons, and other things like that. Our GUI element is going to be of a certain size and it's going to be located at a certain position. The position is going to be represented by the coordinate located down here in the bottom left-hand corner. The position is a 2-dimensional vector which is going to contain the x and y coordinate of this location right here. In addition to requiring to know the position, we also need to know the size of our GUI element. So we're going to have another 2-dimensional vector which is going to contain the horizontal size as well as the vertical size of our element. All our elements are going to be rectangular in shape so that always the size is going to be horizontal and vertical like so. If we want to have a round GUI item, like a round button, that's perfectly fine. However, we have to realize that the description of our GUI elements are going to be with respect to this position here and with respect to the size that's given by the width and the height. Each GUI element is going to have a hotspot, and this hotspot is going to serve as the region that the user has to place his cursor over top of before some sort of interaction can happen between the GUI element and the user. So the hotspot here is represented in red. However, the hotspot can be larger or smaller or the same size as the actual GUI element. And you'll see this once we actually start working with a button in the next VMK. But just realize that the hotspot size does not necessarily have to be the same size as our GUI element. Because we have a hotspot size, we also need to have some sort of offset. And this offset is to locate this bottom left-hand corner. So if the size itself is smaller than the actual size of our GUI element, then we're going to need to position it accordingly. So we're going to position it using this hotspot offset value, which again is a 2-dimensional array, and it's going to be the offset with respect to the current position. So for instance, this GUI element could be located at 100, 200, and this offset here could be something like 10 and 20. So to get this coordinate here, you take 10 and 20 and add it to the position to get this location here. Just regular vector math. There are 2 additional parameters that we're going to be recording for every single GUI element, and those are over and pressed. So in total, there are 4 different states that each GUI element can reside in, and these states are displayed here. So imagine that our cursor is not anywhere close to our hotspot of our GUI element. That means that we're not over top of our GUI element, and we have not pressed our GUI element either. So initially, this is the state that we're going to start off in. We're not over it, and we haven't pressed it. As the user moves his cursor towards the GUI element, and it goes inside of the hotspot region, then the over flag here is going to trigger to let us know that we're over top of our GUI element. At this point, we may want to do something like highlight the GUI element if it's a button, or if it's text, maybe show that the cursor is over top of it, something like that. Once we're over top of it, we can press the button on the mouse, at which point we're going to trigger this press state, and it's going to toggle to be on. So at this point, we're over top of it, and we've pressed the button. So now we can also change the state of our GUI element. We could maybe, if it's a button, depress it. If it's a checkbox, we might put a check mark inside of it, something like that. And then the final possible state is the user actually moves his cursor away from the hotspot. So it has been activated, so it has been pressed, so there's a 1 here, and we're no longer over it, so we have a 0 here. These are the 4 individual states that a GUI can reside in. If you need to have additional parameters or additional states, you can add those in, but with all the GUI elements I'm going to be showing you how to develop, these are the 4 states that we're going to be working with. Okay, now that we have that out of the way, let's go into Visual Studio and actually implement this base class. We're going to place it inside of our object library, so go into Solution Explorer, and under Object Library, select Add New Item. We're going to create a CPP file. We'll call it GUIControl, and we'll repeat this for the .h file as well. Okay, so here's our GUIControl class. At the top, we're going to create an enumeration, and it's going to be called GUIType, and this is going to specify what kind of GUI element we're going to be working with. The options are that we're going to have a button, we're going to have a text field, we're going to have a radio button, or we're going to have a slider. If you want to create your own custom GUI elements, you're going to have to create a new GUI type here inside of this enumeration. Then we have our class. We have a constructor which passes in the GUI type that we want to create. We have a virtual destructor. We have a function here that will return the ID number for a specific GUI element. We have some functions to return the position as well as setting the position. And a Boolean check here to see whether the GUI element is pressed. There's another check here to see whether the mouse cursor is over top of our hotspot. And then finally we have 3 virtual functions. We have check hotspot, stop pressing, and render. And I'll talk about these in detail in the next VMK, so don't worry about these for now. Our member variables consist of the type, which again is the same value that gets passed inside of our constructor. We have the ID number. We have the position, the size, the hotspot offset, and the hotspot size. And then finally we have our Boolean values for whether we're over top of the GUI element and whether the GUI element is pressed. And that's basically it. Now let's go inside of our GUIControl.cpp and implement some of these functions. At the top we have our constructor where we pass in the kind of GUI element we're creating. Because we've defined our GUI type here to be constant, we need to define it using the colon and then m_type with bracketed type parameter passed in here. So this guy gets passed into here for this variable, which is constant. From now on, we're not allowed to change the value of m_type. We set the over and the press state to be false, so initially all of our GUI elements that we're going to be creating are not activated and our mouse cursor is not located over top of them. Our destructor doesn't do anything. Here we have our accessor functions for our member variables, and you'll notice that all of our member variables are protected. They're not private because we're going to be using this class as the base class to inherit things from. Now if we place all of these guys under the private section, all inherited classes wouldn't be able to see these variables. So we need to make them protected so that the user outside of this class can't access them, but all inherited classes can still use these variables. So going back into here, if we want to get the ID number, we need to use this function getID. If we want to get the position of the x or y coordinate, we're going to use these functions here, which return the position x coordinate or the y coordinate. We also have a function here to set the position for the x and for the y coordinate. And then we have one more function here to return whether the current GUI control item is being pressed or not. So it's going to return that member variable. Lastly, we have our check here to see whether the mouse is positioned over top of the control's hotspot. So going back into here, our hotspot is defined by this position, this offset, and the hotspot size. So the way we check to see if the mouse is over top of this region is we first check to see if the mouse coordinate is greater than the position, which is this boundary here, plus the offset, which is this boundary here. So if the mouse is greater than those two values, then we're to the right of this boundary. And then we check to see if the x-coordinate is less than this position plus this offset plus the width, or the hotspot size in the x-coordinate, which is this boundary here. So we're checking to see if the mouse is between this left edge and this right edge. We do the same thing for the y-coordinate of the mouse by checking to see if we're greater than the positions y plus the offset y to see if we're above this line, and then we compare to see if we're below this line here, which is the position y plus the offset y plus the hotspot size in the y direction. If all of those are true, then we are inside of the hotspot, which means that we can then return true from our function. So let's see this here in code. We check to see if the mouse position x is greater than or equal to the position x plus the hotspot offset x, and whether the mouse position x is less than the current position x plus the offset plus the hotspot size in the x direction. And then finally we check the y-coordinate, which is the vertical, so we check to see if the mouse y is greater than or equal to the position y plus the offset y, and if the mouse y is less than the position y, offset y, plus the hotspot size in y. So if all of this is true, then we're going to return true, saying that we are over top of the hotspot. Otherwise, we're going to return false, saying that the mouse is not over top of the correct location. So that's it for the GUI control. Let's go and compile this and see if everything's okay. GUI ID. This is another enumeration that we need to define, and we have to make it accessible to our program so that all of the ID numbers will be visible from our code as well as from all of these classes. So to handle this, what I've done is I've gone inside of core.h and implemented the enumeration there. Let's open this guy up and add our enumeration. I'll just add it here underneath our action. These are all the buttons and controls that we're going to be creating in the next few VMKs, so don't get overwhelmed yet, but get the general idea of what's going on here. We're going to have GUI ID none, which is the default value, and then for each control that we're going to be adding into our game engine, we need to create a new ID number. And by using enumeration here, we can see that the compiler will automatically increment the number as we start stuffing new values inside of this enumeration. So we have the main screen, there's going to be a button, and it's going to be called Start New. Then we're going to have another one on the main screen, which is a button for options, and another one on the main screen, which is a button to quit. Then under options, we're going to have all these different items. Under pause, we're going to have 3 options, and then under the pause menu options, we're going to have a few additional controls here. So again, this all depends on how you want to structure your own game engine and what kind of options you want to give. But these are the ones that I'm going to show you how to create so that you can get a good feel for introducing things like checkboxes, slider, text fields, images, and regular buttons. So now that that's implemented, let's go and try to compile this again. And okay, so now it succeeds. This class is ready to use to start creating our first inherited class, which is going to be the GUI button. So come back for the next VMK where we're going to implement that.